Energy. What is it? Energy is defined as the ability to do work. Anything that moves or changes is driven by one form of energy or another. Energy is in the light, heat, the sound, and everything that is dynamic in the universe. From prehistoric times, man has had to harvest the energy of the earth in order to have the power to work, live, and survive. And just as human activity and work has evolved over millions of years, so too has our demand for energy. Today, our existence and survival in this modern world depends largely on how we acquire, distribute, and use energy. From the food that gives an individual the strength to go about his or her daily business, to colossal plants that supply the energy that powers almost every aspect of our modern lives. Fire was one of the first forms of energy that man was able to harness and put to his own use. We cooked, lit our nights, and protected ourselves with fire. The flames we see and feel when a fire burns are the result of a process called combustion. Combustion occurs when oxygen combines rapidly with other substances or fuel to produce heat and light.
Like all organic matter, wood is a carbon-based substance. When we say organic matter, we mean matter that is or once was alive, whether as animal or plant. On Earth, all living creatures are composed mainly of two elements, carbon and hydrogen.
For a great part of human history, the chief source of fuel for the fires which lit and heated caves, cooked food, ran factories, and powered engines was derived from the burning of wood or coal. Coal is simply decayed plant matter that has been compressed over a great number of years by layers of sediment being deposited on top of it. It is this coal that is now mined and used as fuel. Because the process by which coal forms is the same as the process which gives rise to animal fossils, coal is called a fossil fuel.
Besides coal, other fossil fuels like petroleum and natural gas are also trapped beneath the Earth's surface.
Interestingly, the word petroleum is a Latin word which combines the Greek words petra for rock and the Latin word oleum for oil.
The reason the Greeks call this black liquid rock oil is not very far-fetched. They first encountered it when it seeped through the Earth's surface through cracks in the rocks, hence petroleum. Raw petroleum, or crude oil, is a mixture of a number of useful hydrocarbons that are separated when the oil is refined in a process called cracking.
The various hydrocarbons are used as fuels and as material for manufacturing many of the products we use every day, like plastics, textiles, tires, and even bubble gum. Although the actual mining of crude oil began in 1908, Trinidad and Tobago's long history as one of the world's foremost suppliers of energy began when crude oil deposits were discovered in Trinidad back in 1866. Later, in 1912, our first refinery was constructed. As early as 1950, power generation from natural gas had already commenced in Trinidad and Tobago. 1954 marked another progressive landmark when marine drilling began off the west coast of Trinidad.
In 1972, the country's total gas reserves were estimated at 90 trillion cubic feet.
Today, the oil and gas industry accounts for 25% of the gross domestic product of Trinidad and Tobago
and is one of the largest providers of employment in the private sector. Locally, the industry has an investment base valued at over $330 billion in plant and machinery alone. From the late 1800s, oil was already becoming an alternative to coal as the world's main source of fuel. Gasoline and dieseline, which are byproducts of petroleum, are used to power the internal combustion engine. This engine has played the single most significant role in the evolution of the aviation, automobile, and manufacturing technologies that have shaped the way we live and work today. By the turn of the 20th century, petroleum started replacing coal as the fuel of choice for driving the large turbines in many of the world's major power plants.
Petroleum, however, is a non-renewable resource. This means that unlike sunlight or wind, the deposits of petroleum on the Earth are finite. There is only so much and no more. Additionally, not all deposits of petroleum can be reached or mined. Here in Trinidad, for example, the reserves that we can mine or which are retrievable are estimated at an amount that would last for the next 100 years or so at the current rate of extraction. Additionally, the refining of petroleum is expensive and produces a number of waste products that contribute to the pollution of the environment. Therefore, the search for a more abundant, cleaner burning source of energy continued. Today, natural gas has become the fuel of choice and of the future. Currently, over 25% of the world's energy consumption needs are already being met by natural gas, and this figure continues to grow annually. In prehistoric times, dead animal and plant matter were washed into the sea. This material was deposited together with mud and silt. Under the intense pressure placed on this organic material by the weight of the rock, which formed above it, the material changed into what we find today as petroleum and natural gas. The principal component of natural gas is methane. Methane, the simplest hydrocarbon, is a chemical compound composed of one carbon atom and 4 hydrogen atoms. Its volatility comes from the fact that this molecule readily combines or combusts with oxygen to produce carbon dioxide, water, and heat energy. It is this explosive power of methane that gives it the ability to drive an engine.
In Trinidad and Tobago alone, reserves of natural gas are estimated at over 19.7 trillion cubic feet. But how do we know where to find these deposits, and how do we estimate their size?
Once an area is designated for exploration, geoscientists begin conducting specific tests to determine whether gas or oil are present in the area. They first study the terrain or geological formations above ground to determine where deposits might most likely be present. In areas where wells already exist, the scientists may study rock samples that were obtained from drilling, as well as information acquired from instruments lowered into wells to measure the properties of the different rocks, which could indicate the presence of natural gas deposits. Scientists also use seismic data. This data is gathered when sound waves are projected through the surface of the Earth, and the quality of the sound that returns as it bounces off the different types and layers of rock or other substances is collected and analyzed. This process resembles echolocation used by animals like bats when they emit high-pitched screeches that bounce off prey or objects around them, allowing them to make a picture of the environment. Similarly, computer technology imitates the natural form of echolocation, and seismic data can be used to create a considerably accurate three-dimensional picture of what lies below the surface well before drilling commences. Once scientists are reasonably convinced that a site is suitable for drilling, the expensive process of seeking governmental and environmental approval to proceed with design, installation, and activation of a well can begin. In the case of natural gas, once a well is successful, the precious substance is then transported by pipeline to plants like Atlantic LNG in Point Lisas, Trinidad. The gas may then be transported directly to the industries that use it, or to power-generating plants like PowerGen. Gas is also exported to other countries like the United States, Spain, and Puerto Rico. To transport gas to these distant markets, it is first cooled to the very low temperature of 160 degrees centigrade. Remember, water freezes at 0 degrees. At this ultra-low temperature, the gas changes into a liquid. This means that 600 cubic feet of gas can be cooled and compressed into a single cubic foot of space, allowing it to be transported by ocean aboard specially built tankers. The modern exploration and mining of fossil fuels bring a wide array of technology, equipment, and expertise together in what is called the energy industry.
Geologists and geophysicists play leading roles in the exploration process, but they are not the only scientists in the industry. The mining of any substance changes the natural distribution of minerals on the planet.
This may create potential risks to the environment. Therefore, biologists and environmentalists are also a key part of the industry. Other scientists, like physicists and chemists, also work in the industry, studying and advancing the kind and quality of scientific information that allows the industry to grow and develop.
Chemical and civil engineers, drilling and electrical engineers, mechanical and petroleum engineers all work in the petrochemical industry. There's also a diverse array of technicians that work in the industry at the many stages of the extraction, refining, and shipment of the resources.
Control workers and equipment operators ensure that all systems are fully functional to allow the gas or oil to efficiently flow through the system. Oil field workers include derrickmen, drillers, roughnecks, and roustabouts. Machinists, maintenance workers, welders, mechanics, and electricians are the people who literally make things come together.
And although they don't work directly in the oil fields and seldom come in contact with the actual process of mining and moving the oil and gas, there's a whole army of management, administrative, marketing, legal, and accounting professionals who contribute substantially to the success of the industry.
This category of professionals
Also includes individuals who work in governmental and international agencies and offices responsible for monitoring and regulating the industry. Altogether, these highly trained and skilled men and women make the industry one of the most efficient and productive on the planet.
We have seen that in our modern world, almost every aspect of life is influenced by the energy and products derived from oil or natural gas.
It is this reliance on these fossil fuels that make them two of the most valuable natural resources on the planet.
And we have seen the valuable part that Trinidad and Tobago has played and will continue to play in supplying the world's increasing need for energy.